All right, so we have 4 minus root 6. We're going to multiply by its conjugate, which is the exact same thing as these two terms. But because this one has a minus sign in between, I'm going to put a plus sign in between. So it's just literally the sign in the middle swaps. So if it's a minus, it becomes a plus. If it's a plus, it becomes a minus. And it'll make sense why the heck we do that rather than just memorizing. Because what do I think about memorizing? Scary, because you can memorize and not know it fully and then switch it, right? If you understand why, it makes more sense. So this is why we multiply by a conjugate. Let's FOIL and see what happens. So we're going to use, let's see. Okay, so we do first times first. 4 times 4 is what? 16. Then we do outside. 4 times root 6 is 4 root 6. We agree? And I told you the reason why we multiply by conjugates is to get radicals to disappear. And you're like, dude, there's a radical there. You're a liar. Just wait. Just wait. Now, inner terms. Negative root 6 times 4. What would that be? Negative 4 root 6. What happens with these two middle terms? They cancel. Why did they cancel? Because I used the conjugate. Because I used the opposite sign. And because I used the opposite sign, my outside two terms will be the opposite sign of my inside two terms multiplied, which means they'll always cancel. So if you use the same sign, they're not going to cancel. If you use opposite signs, they will cancel. Okay? And then you're like, but wait, they're still radicals. Well, let's see. So we do last times last. So negative root 6 times positive root 6 is negative, because it's negative times a positive 1, right? We can just do number ones in front. And then what's root 6 times root 6? 6 in brackets. It is root 36, but then you have to do an extra step and drop it down to a 6. Remember when we had the same radicals, we just bypass that so that we don't accidentally mess it up in that step, because that happens. So root 6 times root 6 doesn't just become 6. Root 6 times root 6 becomes 6 in brackets every time. Now, really, if you didn't this time, you used luck out, but it doesn't matter. Do I have any radicals left? Did the radicals all go away? Yes, because I multiplied by the conjugate. That's the point of multiplying by conjugate. Your radicals will disappear, evaporate. Gonzo Alfonso. So now we have 16 minus 6, which is 10. And I got rid of all of my radicals. And the reason why we're going to need to do that is we always have to have a denominator at all times without a radical in it. That's the rules. It's called rationalizing the denominator, which means getting rid of the radical. Okay? So how do we know how to get rid of a radical? Multiply by conjugate. So when you have two terms, you multiply by the conjugate. Okay? You're going to try this one. 4 plus root 6. David, what do we multiply by?
You can multiply it by 4. Yeah.
4.
And then negative
minus
6.
Root?
Root 6.
Yes.
So you just copy this, right?
Intentionally, because you were sidetracking. Okay, 4 times 4 is 16. Then 4 times negative root 6 is negative 4 root 6. 4 times positive root 6 is positive 4 root 6. And I should be able to, after this step, immediately cross those off. If I can't, I did not multiply by the conjugate. I multiplied by something else, right? And then what's a positive 1 times a negative 1? Negative 1. And then what's root 6 times root 6? 6 in brackets. So we get 16 minus 6. Weird. What? We got the same answer. Why? Because it's the same thing. Multiplication, you were taught, I don't remember when, I think it was grade 4, that if you do 3 times 2 or 2 times 3, you get the same answer, right? I think they started teaching multiplication in grade 3, actually. In grade 3, you were taught that you can plot multiplications, right? But divisions, can you plot divisions? No, all those negative-y things you can't do. So addition, you can do it, right, Abby? You totally do this with addition. But subtraction, can we do that? No. Multiplication, can we do this? Yes. Division, can we do this? No. So it's just with addition and multiplication. Okay. Game on. We're going to divide now. So dividing radicals. Divide the coefficients and divide the radicands. Always rationalize the denominator what contains a square root. That's what I told you, right? You can't have a radical in the denominator. If you do, you're not done. Keep going. Okay? And if the denominator contains the square root binomial, then find the conjugate of the denominator, multiply the numerator and denominator by the conjugate, and simplify. Okay. What we were just doing had two terms, correct? When we have two terms, we actually have a conjugate. Same thing, different sign. Okay? This is what you're going to have to use your bean here, your head for. If I have single ones, so we just did conjugates, we'll use them in a second. But if I just have single radicals in my denominator, okay, if I have a square root of 6, how the heck can I get it to go away? What did I do? What could I multiply it by to get the root to go away? Square root of 6. The square root of 6 times square root of 6 was 6, right? Now let's go back to fractions, way back in the day. Don't whine, it'll be fine. Okay, so if I do a half, you're not writing this, you're just paying attention. If I do a half and I want to make it be actually out of 6 pieces, okay? And I still want half the pizza, you're like, 3, left, duh. That doesn't matter. We're going to pretend we're not that smart. So I need to have 6 pieces. So I multiply the bottom by 3 and I get 6. What do I have to do to the top? Multiply it by 3, or else it's not actually the same fraction, is it? 3/6 is equal to a half, correct? But a half is not equal to 1/6, which is what you guys are going to do in these instances. So if I want to make the same thing, if I want to multiply just a single sole fraction sitting in front of my face, if I want to multiply the bottom by something, I have to then multiply the top by, or you've totally changed it. Have you not? We just said it here, right? If I multiply the bottom by 3, I have to do to the top, or I've totally changed my fraction, correct? Remember that. Same thing here. These are just fractions with radicals. I know you hated fractions before, but these are just so much better. It's like super fun. It's a gift. You're welcome. It's your Friday gift. Okay. So, I have a root 5 in the bottom. I told you my biggest rule is the root 5 needs to go away. Right? Needs to go gonzo. I can't have a root in my denominator. How do I get rid of the root? Square root 5. David? Times by square root 5. You're going to be like, I can't do this, and then you just answer my question, sir. See? You're a genius. Square root 5. So, what I tell you, if you do it to the bottom, you have to also do it to the top. Now we're going to use our multiplication rules. Remember I told you, if you stink at multiplication of radicals, this is going to be real awful, because you're just multiplying. Okay? So, do the bottom first. Root 5 times root 5 is?
5 in brackets.
5 in brackets. Now, if there's nothing else beside it, we're going to be able to drop the brackets off. But remember, in all those multiplications, we still needed it, because we needed to multiply by the coefficient. Okay, the top, root 20 times root 5 is root rhymes with 100. Yes, 100. And root 100 is 10 over 5. This actually worked out to something pretty. A half. And by half, I mean 2. It's recorded, isn't it? Nah, I can't even pretend I didn't do that. It's 2. It's 2. It's 2. Now, if there happened to actually be a radical in the numerator, could it stay there? Did I say anything about radicals can't be in the numerator? Nah. Radicals can be in the numerator all they want. It just can't be in the denominator. It's called rationalizing the denominator. Okay? Ooh, look at that. There's a lovely little one there for you, and it says try. I think you should try it. Go ahead. Root 15 is my issue. What am I going to multiply by? Root 15. And why? Not because you memorized it, but because root 15 times root 15 is 15, and it makes it go bye-bye, right? That's the reason why we do it. Our rule is we see a radical in the denominator, and we need to make it disappear like magicians. So how do we do that? We multiply by what it is. We know that makes it disappear. We've learned that for days now, right? So we're going to multiply by root 15 and root 15. Could we reduce this 90 first and then not have such a big number to deal with? Could we have done that? Reduce the 90, made it be 3 root 10?
Yeah.
Sure, absolutely could have. Okay, I'll show you both. So, root 90 times root 15 is something really large. What is it? 1,350 over 15. What's the biggest square root that breaks into? And if you're like, I didn't know I needed to reduce, you always need to reduce. It's not a, sorry? 225. I like your spirit. This is good because I didn't have to figure it out. So 225 times what? 14. What a lovely number this time of day. Okay, and then 225 comes out and it's up 15. Oh my goodness, life is getting better in seconds here, guys. 15 root 14 over 15. If it's literally just a coefficient and a number on the bottom, they can cancel off. And we can get an answer of what? Yeah.
I just have a question.
Yeah.
225 times 6 is 1,350.
Times 6?
Yeah.
Well, I like, yeah? We agree? Okay, I like 6 too. It's a good number. 14 and 6 are beautiful. Either way, I'm going to get root 6 then. Not going to lie, I didn't really care about the second number. The 225 was my biggest kick. But yes, it does make sense. There to be 6. So, could I have reduced the 90 first? Let's do that so we didn't have such a large number. Let's try that out. So I could have went 3 root 10, because it'd be 9 times 10 over 15, right? Then I can times by root 15, and by root 15, and then I would have gotten 3 root 150 over 15, and then root 150 is 25 times 6 over 15, and then the 25 could come out and be a 5, which would get me 15 root 6 over 15, which is root 6. Did the answer change? No. So you can reduce them first and not have to deal with 1,350, which my brain couldn't just do. But 150 my brain could cut down, as I was calculating. Okay? What happens if we got ourselves some variables? I know this is when you guys like get super excited and happy when you see the variables. Because these are just too simple. You're like, no girl, give me some variables. You're all so happy about it. You guys all do not like the variables. I've come to note that. There were so many sadnesses when I see the variable question. But we're going to change that to positivity. All right. So this one, we have root 5x over 7. That's my problem. Do I want to reduce the 45x cubed first? I might want to, because I don't like the really ridiculously large numbers. So I'm going to reduce it first. So 45, I can break down into 9 times 5 and the x cubed, right? And the bottom, I'm just going to leave, because it's sometimes more complicated to touch it. So up here, I'm going to get a 3, and the x cubed, I can take 2 out. I can take 2 of these out for 1, so I get an x, and I'm left with 1, and this is gone. So I have 3x root 5x over root 5x to the 7. Now, my biggest issue is I can't have that square root on the bottom, right? How do I get rid of a square root 5x plus 7? It's nothing crazier than the other one. I just need to multiply it by? Yeah. Yeah, it's the exact same thing, right? So I get 3x. Now, do these cancel? Are they the same? No, so then I actually have to do the math, right? So I'm going to get the square root. 5 times 5 is 25. X to the 1 times x to the 7 is x to the 8. And then 5x7 on the bottom. And you can put in brackets or not. Can I reduce that radical actually on the top? It's actually going to completely go away, isn't it? The square root of 25 is 5. I wasn't even showing that, but I guess I was subliminally giving you messages. I didn't even know I was doing it. Square root of 25. Yeah.
Why is it 5 by 7? 5 by 7? Didn't it cancel out?
The square root of 5x7 times square root of 5x7?
Oh.
Yeah.
Okay.
I was like, I may have made a mistake. It's happened. It's real. Okay, so square root of 25 is 5, and the square root of x to the 8 is x to the 4. Literally cuts it in half, right? So this is going to become 5x4, and then that's going to go away. You agree? So on the top, we're going to get 3 times 5, which is 15, x to the 1, x to the 4, which is x to the 5, over 5x7. Now, this is only going to be able to reduce because between both of them I have what operation happening? Like between the 15 and the x to the 5. What operation is happening between them? Multiplication. So only because there's multiplication between these can I cancel off if the coefficient matches and if the variable matches. Only if there's a multiplication, okay? Paying close attention. If there's a plus sign in between them, nothing. Walk away. Can't do anything. Multiplication, then I can do coefficient divided by coefficient and variable divided by variable. Make sense? So that's a multiplication. So 15 and 5, I can take a 5 out of both. 5 divided by 5, I get a 1. 15 divided by 5, I get a 3. And then 5, there's 5x's up here and 7x's down here. So these 5 cancel off 5 of these, so how many I left on the bottom? 2. So my answer is really 3 over x squared. Done. So for the try, I would reduce the top. But the bottom, what do we multiply by? Some people want to multiply by the conjugate. Is there a plus or minus sign in between here? No, it's a multiplication. And my issue is the square root 6. The 4 is fine, right? There's no problem with the 4. So what am I going to multiply by? Square root 6. Some people want to multiply by 4, but why? There's no point, right? I just need the square root 6x to go away. So I'm going to multiply by square root 6x. So you try this one out. But I would personally, myself, reduce that numerator. Up to you, though. All right. So here we have root 6x in the denominator, but I told you I would reduce this first. So I'm going to go up here and reduce it, because I don't have a lot of room. So 18x cubed with an x in front. So the 18 I can rewrite as 9 times 2, x cubed, right? Remember I told you if you go x times x times x and take 2 for 1 out each time, please. Like if that's the way you can do it, you do it that way. So I take the 9 out, and it becomes a 3. I can take 2 of these x's out, so I'm left with 1, and I have an x up here. So this reduces to 3x squared root 2x. So first thing I'm going to have is 3x squared root 2x over 4 root 6x. And then I told you our problem is the root 6x, not the 4. So we're going to multiply by root 6x in the top and the bottom. So we're going to get 3x squared root 12x squared over 4, and then root 6x times root 6x is just 6x in brackets. So when multiplying or dividing, the very first thing I always do is if I can reduce anything, I reduce it first. Then I actually do the operations, right? Now, the 12 can break down into a 4 and a 3. X squared over 24x. The 4 comes out and it becomes a 2. And the x squared comes out and it becomes a x. So we'd be left with 2x times 3x squared 2 times 3 is 6. X squared times x is x cubed. Root 3 over 24x. Now, what I need to sell to you right now so that you don't ever do this is you can never go to your square root sign and just cross it out. You can't be like something down here matches it and cancel it off. It's the coefficients that can cancel. The only way you can get something out of a radical is making a perfect square and taking it out. Okay? That's the only way. We've been doing it. It has to be an arrow and you have to be able to bring it out. You literally can't just like cross, go, oh, I can take a 3 out of all 3 of these. 2, gone. You can't do that. Okay? We can do the bottom, or the coefficients, because they're just multiplied and there's no plus or minus sign. So these are multiplied. So I can cancel these off, but that root 3 is staying root 3 for life, because the only way it can change is if I can take the perfect square out of it, and I can't. It's root 3. So 6 and 24, I can take a 6 out. 6 divided by 6 is 1. 24 divided by 6 is 4. An x out of here, and an x out of here, so I get an x squared. So I'm going to get x squared root 3 over 4. Now these, I'm afraid, you have to do really, really well, because these are the easier ones. Because what happens is, we're going to move on to these ones, where we still have a monomial in our denominator, but we have a binomial in our numerator. And then we're going to move on to these ones, where we have binomials in our numerator and have to multiply by conjugates. So, we need to practice these. And a little reminder again, when you get to your 30-1 teachers class next year,